presenting on code smells. Ooh, that smell. So the agenda of today's talk is we'll go over what are the code smells, why do they occur, what is their impact. We'll go through some of the code smells and we'll go through some real world example code. So, so these are some interesting barrier conversations we often hear, which kind of tends to code smells like we'd better not touch this code. Last time we did dash dash dash. I thought we had a test for this. It always worked. Who touched it? Where is the email about this issue? Assigning this to person X who will come back on next Thursday and solve it. Just add a to do command for now. Let's put a hack for now. Let's create a sim for refactoring for now. Let's deliver results for now. So what are the code smells? Code smells are anti-patterns which represents hazards in the code. It's a design that duplicates, complicates, or tightly couples the code. Another similar term we commonly hear uses like called technical debt. Uh, so recognizing the hazards in the code is first step in the improving the code. Why do they occur? There are two prime reasons why the code smells occur. One is consciously, it's not right, but you kind of deferred the design improvements or refactorings of the code. Unconsciously is when you don't know, you are not aware, and you miss them in the development as well as you miss them in the CRs. Then what is the impact of this? So as the months or years pass by, then the cost of change of the code or the technical debt or the refactoring or design improvements increases, and the customer responsiveness decreases because when you are doing some code, then you have the major context of that code, whereas few months down the line you lose the context, and this and the cost of change increases. Now let's go over some of the code smells. First one is lost intent. Just like the traffic sign is obscured by the shrubs, your code may be obscured by complexity, unintuitiveness, and poor organization. Code that does not communicate author's intention, it's very hard to understand, extend, and modify. Let's take an example here. So in this example, you would see the first loan class, right? It has got a lot of constructors, but you don't know which API to call to create a term loan. Whereas in the second example, it's got a single constructor which takes all the arguments, and it has got well-defined APIs to create term loan or to create a recursive credit term loan. It's a very clear-cut API, which is very intuitive. Another is inefficient naming. So let me take an performance optimization problem here. In this pseudo code, if you see, we have a for loop which is like 1 to 50. It goes read, and then inside the read loop there's another for loop which does scan from 1 to 50 and write. So for one write call, there are like 2500 scan calls which are happening and 50 read calls which are happening. Assuming all these calls take 100 milliseconds, uh, to optimize performance, the best to optimize is the scan call. Even if you save 10 milliseconds in scan, it'll the net save for this program would be 25,000 milliseconds, which is awesome. Now, okay, now this was not a program. It's programming itself. So in programming, what do? We read code, write code, scan code. So when you're writing code, you need the maximum depth of the detail. It should be right in your head. You should have a very tight focus. When you're reading code, you need to read line by line, and you need to understand what that code really means. You need to focus. Whereas while scanning code is like broad level, it's a rough detail. Like high level, you should know where the code is. It's kind of discovery mode to discover where to read. Now, you often flip between scanning, reading, and writing. The main time you spend is in scanning, then less in reading, and then in the writing code. Now, bad names, naming convention for variables, methods, or classes, they affect the scannability of the code very much. So, if you improve the improvement in the scannability of code, right, will improve the performance, programmer's performance. Now let's take an example in a game where we have to write a function on getting the direction of the soldier where he's facing. So the best is to use get direction, because get dir is misleading it, because dir also means directory, and get drctn is also not right because it's like shortening a vowel is bad. Another is I have seen like people using temp variables a lot, which is kind of like impeding the scannability of the code, which should be avoided. Next code smell is duplicate code. You should try and avoid duplicate code. Taking an example here, like these no parking signs, three no parking signs placed next to each other is not adding value. Even one would have been sufficient. So duplicate codes is of two types. One is blatant, other is subtle. Blatant is like exact copy paste. Subtle is like you need to read final lines to detect yes there is a duplicate code in there. Now let's take an example. We have two classes, form tag and link tag, which extends the node class, and it has got same API. There's just minute difference of get all nodes vector in form tag and get link data in link tag. So you could have very well extracted the APIs into the base class and remove the duplication of code here. Next is comments. So comments are like deodorant. You should not use it. Your code should be intent revealing. It should be self-explanatory rather than putting comments, because comments often go out of sync from the code. So that said, you can still use comments if they are links to some sim, TT, or wikis, to augment the code or add traceability to the code with respect to documentation. Okay, next is long method. There's a long method is like a large bug which is very hard to digest. Shorter and compose methods are often preferred. They are more readable. It provides a great opportunity for code sharing and less of duplication. And it's also very easier to test. There's often a misconception that longer methods are not performant than shorter methods, but with Java and all, like they do inlining and all, so you should not care about those things. Then large class is kind of Swiss Army knife. Um so a class should not take too many responsibilities. Uh, so often I see classes with like common utility, those kind of things, which are kind of like dumping grounds and which have got um, so you should avoid those classes, and you should have proper classing hierarchy. Then coming to the dead code. So even if you have a pet goldfish at home and it meets an unhappy end, so it's always uh, you always dispose it rather than keeping it, otherwise it will smell. So similarly, you should always keep on removing the dead code, otherwise it will lead to increasing complexity or accidental changes, or it can produce more dead code. Often there is a fear of deleting the code, but if you have a comprehensive test coverage and you know which code is getting touched and which code is a dead code, then uh, it's easy. So there are some tools available like Jacoco test coverage, etc., which will tell you uh, the whether your code is a dead code or not. Then coming to oddball solution. So oddball solution is when a problem is solved one way throughout a system and the same is solved another way in the same system is kind of called of oddball solution. So example would be, let's take an example here. We have three classes which extend action. So we have uh, they override the process API. So in two of the classes, it returns calls the process API and passes the argument view action. Whereas in show login action, we refactored it and it returned the view action method, which is much better because if you change the view action parameter later, then you might have to change at n places rather than at a single place. So here we are entering into kind of oddball solution. We should, when we refactored the show login action, we should have also went ahead and refactored the upload action and load user profile action. Then next mail is primitive obsession. So primitive obsession is basically if you want to open a screw, right? So you will always prefer to use a screwdriver rather than a knife, which is knife is a low level of abstraction, whereas screwdriver is a high level of abstraction. So on the technical lines, in the Java lang string, you have, let's say you want to see whether the string contains a substring. Then there's already a high level abstraction API called contains. You'd always prefer to use that rather than using index of and comparing with -1. Even if you are developing code, you always prefer to use, if there's some open source library or code within your organization, you should always prefer to use that rather than uh, going the primitive obsession way. Then speculative generality, it's often said that, like, let's say you're building things for future and thinking too much about the future, like let's say you want that ability someday and building it today is called like speculative generality. A common example would be you're writing some extra code to handle some complicated scenarios when application requires support only for some simple scenarios today uh, is called like speculative generality. Then having an interface and an abstract class and an implementation class, and where abstract class doesn't have any method itself, creating that abstract class is an overhead. It's not required today. Is again a speculative generality. You can just get rid of that abstract class. Then next smell is combinatorial explosion. So given this example, let's say you have a list and you have a uh, you have inherited class array list. Then you have further classes in array list types like read-only list, sorted array list, or thread-safe list. And then you have the combination of read-only and sorted and thread-safe list. So let's say if another type of list gets added, then these combinations are going to explode, and it's kind of bloated design. So we should not use inheritance here. Instead, we should have used composition, where each of the read-only list, sorted list, thread-safe list has a reference back to the list, and use a kind of decorator pattern to create this lists and decorate it accordingly. Then you have a black sheep code smell. Black sheep is a family member that doesn't fit in so well. It could be a subclass or a method in a class. Let's take an example. We have this string util class which have all the string utility functions, and then we have this extract command name from map, which is kind of like it takes a map and returns a value from the map as a string, which is completely out of which is completely a black sheep. It's not fitting in here well. Uh, Ideally, we should have created a separate class and put that API there if it's not fitting in somewhere else. Then coming to feature envy. Feature envy is like uh, responsibility of performing that particular job or method is in wrong place. It's called a feature envy code smell. So let's take an example of feature envy. We have a phone class and we have a customer class. So customer has a mobile phone, and we have a get mobile phone number in the customer class, which does some formatting on the phone number and returns that. Ideally, this formatting of the phone number should be better in place in the phone class, because there might be other clients who might use it. So, so we in the right side we have put it in the phone class, and the get mobile phone number in the customer class just calls that API. So this was the feature envy code smell. Then coming to the refused bequest, let's say if subclasses gets to inherit the methods and data of their parents, but what if they don't want or need what they are given? Is called refused bequest. Uh, so in Java Collections API, we have abstract collection, and in that abstract collection, we have a method called abstract add method, which adds the object to the collection. So this abstract collection has three children like map, set, and list. So for set and list, they have like single elements. So it clearly fits in well. The add method clearly fits in well. But for map, it's always a key value pair. So having an object doesn't fit here well, which is a refused bequest. Then there are other smells like long parameterized list. The more the parameters, it's difficult to read. And let's say if you have more than 6 to 7 parameters in a method or a constructor, always prefer to create and pass an object. Then indecent exposure is like behavior of classes that unnecessarily expose the internal. So you should be very careful about the access levels and have a proper data data encapsulation for your objects. So the opposite of indecent exposure is proper encapsulation, data encapsulation. So we have a collections API. In the collections API, we have unmodifiable list and unmodifiable set, which internally instantiates inner classes of unmodifiable list and set. And so the clients don't need to know about them. All they need to care about is to call these APIs and to get the unmodifiable list and set, which is a perfect example of encapsulation or data hiding. Next, let's run through some example code and find the code smells in that. So here we have a class called orders writer, which basically has a method called get contents, which takes your order object and it returns the XML of the order object. So the way it is structured is we have a orders tag, and in that orders tag we have a list of orders, and in each orders we have list of products. So we have two for loops. One is to iterate over orders, another is to iterate over products. And in the products we have price, size, and other color, other parameters. So we have used a string buffer here, which is kind of appending and creating this XML. So the first quote smell is the long method. You can see it's spanning across multiple number of lines. Then there's a code duplication here. Contents.append is clearly a code duplication where we are doing. Then there's clearly a primitive obsession here. So we have used string buffer and we are creating this XML in this method, whereas we could have used some higher level of abstraction to abstract these things out. Now let's see how to refactor this method. So we have created a high level of abstraction called tag node, because each of this represents a tag in the XML, and we have methods like add to the tag, and then add value to the tag, and add attribute to the tags. Then then we have a method called get contents, which will call another API write orders to. So in write orders to, we iterate over the orders. We create a order tag. So here we have created the orders tag. Then in orders tag we are creating order tag, and then we are iterating over the products, and we are creating a product tag. And uh, so in the orders tag we are adding order tag, each of the order tag, and in the products, in the order tag, in each of the order tag we are adding product tags. So this is the way we have structured these APIs. So we have divided that single API into multiple composed APIs which are doing their work, and we have used this tag node as a to break the primitive obsession thing, and there's no duplicate code in this. Okay, coming back to the presentation, here are some tips, like always code as if the person who will maintain your code is a maniac killer who knows where you live, and always leave the code in a better state than it is today. These are some of the resources I have used refracting to pattern books, and there's a coding horror blog which you can refer to. And thanks for attending it. Thank you.